Hello everyone, hope you're doing great. Welcome to my channel, The Consistent Coder. So the problem we are going to have a discussion is longest consecutive sequence. So this is a LeetCode medium problem, and the problem goes, given an unsorted array of integers nums, return the length of longest consecutive element sequence. So let's look at this example. We have 100, 4, 200, 1, 3 and 2. The longest element sequence is 1, 2, 3, 4. So these are the four numbers that are consecutive, and the longest length is this. The other possible values are 100 and then just 200, because we don't see any numbers like 99, 100 or 101, so that we can call that sequence a consecutive one. There's only 100 and then 200. So the longest consecutive sequence here is 1, 2, 3, 4, which is of length 4. Hence we return 4. So if you look at the example 2, we have the numbers 0, 1, 2, 3, so on up to 8. So we have a total consecutive numbers from 0 to 8, and whose length is 9, which is why we'll return. If we look at the question carefully, here we are given that we are receiving an unsorted array of integers, and then we'll have to return length of longest consecutive element sequence. So basically we are turning unsorted elements into sorted. So the obvious thing that would come to mind is to use sorting. Well, it is mentioned in the question that we must write an algorithm that runs in O of n time, but let's figure out the naive or the brute force solution first, and then from there on we can improve it to make it O of n runtime. Okay. So after sorting these numbers, we'll have the sequence. So this is the example one that I'm talking about here. We would like to mention a point here. So say suppose we have something like 1, 2, and then so on up to n numbers, right? What would be the length of longest consecutive sequence? It will be n. Why? Because these are all consecutive and there are total n elements is what I said. So the longest length would be n, obviously, because all of them are consecutive. Now if I say there is one more number, so in addition to this there is one more number which is n plus 1. Using the previous result, can we make any observation? What would be the length of maximum consecutive sequence here? It will be 1 plus n. So it is kind of obvious because there are n plus 1 elements, but the thing is, since I had n plus 1, the previous number I know it is going to be n because it's a consecutive sequence, and I know the length of longest consecutive sequence I'm going to get if I have n elements is n. So I can simply say 1 plus n is what my complete result would be. So I'm telling this because here also we are going to make a similar kind of thing. So let's see what I'm talking about. See, up until here we have only one element, which is 1. So the length of longest consecutive sequence would be 1, correct? And now since there is 2, what I'll do is I'll check what is my previous number, and if it is equal to 2 minus 1, which is 1, which is actually equal to this case. So what that suggests to me is that whatever the length I have, the longest length I have previously, since 2 is also consecutive to that list, I can simply do 1 plus previous result, which will be 2. Similarly, I have 3. What will be the previous number for 3 in the consecutive sequence? It will be 2, and the previous number is also 2, correct? So what will be the longest consecutive sequence I will have until this point? 1 plus previous result, which is 3. And similarly for 4 also, we have 4, and then I'll do 1 plus previous result, right? Which will be 1 plus 3 equal to 4. And for 100, I'll check what is the previous element. Is it equal to current number minus 1? No, 4 is not equal to 99, right? So that means I don't have any previous sequence for this number to add to, right? So that means I will do simply 1 plus 0, correct? That's it. So which will be simply 1. And similarly for 200 also, I'll check what is my previous number. Is it equal to current number minus 1? Is it equal to 199? 100 is not equal to 199. So which is why I'll simply do 1 plus 0, which is 1. So out of all these numbers, which one is the maximum? 4, which is exactly the longest consecutive sequence that I have in these given set of numbers, which is exactly the answer, correct? So I hope you understand what I'm trying to achieve by sorting and trying to figure out how these numbers by being sorted give us a way to calculate the longest consecutive sequence. But in the question, if you see that the solution has to be O of n, so that means we somehow have to eliminate the sorting thing that we have did here, and then we have to convert this to O of n solution. How can we do this? Let's see. So these are the numbers that we have without sorting, right? So now we need to find out how we can find the longest consecutive sequence without sorting, so that our time complexity would be O of n. But in order to do that, we need to understand some things, right? The first thing is, what are we achieving by sorting the numbers? See, from the what we are achieving from the sorting is that all the numbers which are consecutive are like immediately next to each other, right? So if suppose if I'm asking about what is the longest consecutive sequence at this point, I'm simply checking the previous number, and if it is equal to current number minus 1, which is 4 minus 1, I'll add whatever the longest sequence that I've got until now, and I'll simply add it here. So something like this. But how can we achieve the same thing without sorting? Because if suppose if I'm looping through this array and I'm at the index 1, which is where the element 4 is there. Now if I check the previous element, it's obviously not 3. But does it mean that 3 is not at all there in this array? No. But how can I know that 3 is even there in this array unless until I move all the way through here? Well, you can use something called hash map to know that. So what I can do is I can initially loop through the entire array and I can make a hash map, right? So what am I going to do is, so I'm at 4. Since I have initially looped through this array and then I stored everything in my hash map. So what I'm going to do when I come to the element 4, I'm going to ask, do you have 4 minus 1, which is equal to 3 in your hash map? Well, the answer is yes. This guy will say, I do have a number that is equal to 3. But 3 doesn't offer anything from it, right? I mean, we just know that 3 is there. But in the previous case, when we sorted it, when we know that the previous number is 3, it also offered us what is the maximum length of the consecutive sequence ending at number 3, so that we could simply do 1 plus whatever the number that we got from there, correct? But here in the hash map, we are not getting anything like that. So how can we achieve that functionality? Sure, we somehow found that the number 3 exists in the array by using hash map, but how do we achieve the second functionality that we got from the sorting of the array? Well, what we can do is we can simply do the same thing again. What 4 did is, it asked, do you have a 3? Because that is the previous element that I'm looking for. Now 3 will do the same thing. 3 minus 1 is 2. Do you have 2 in the array? Yes. And then 2 will also do the same thing. Do you have 2 minus 1, which is equal to 1 in the hash map? Yes. So we started at asking the question, do you have a 4? And from there we got to 3, and then from 3 we got to 2, and then from 1 and then from 2 we got to 1, and then from 1 can we go to 0? No, we cannot, because there is no 0 in the hash map. So how many different calls that we have made so far? These are the 4 calls, right? We just ask the hash map, do you have these numbers? And we just keep count how far we can go. We start at the number 4 and then keep decreasing the number till we can find that number in our hash map. So how many times we could decrease this number 4 is the longest sequence, that would end at 4, correct? So for 4, we got the number 4. And for 100, how much we will get? Well, initially I'm going to start at 100 and then I'm going to decrease it. So I'll ask the hash map, do you have a 99? Well, no. So immediately there is only one call. So the maximum length of the consecutive sequence that we have ending at 100 is only 1. Similarly, for 200, it's going to be 1, and for 1, it's going to be 1, because there is no number that ends at 1, and there are no elements before 1. There is no 0, there is no minus 1, there is no consecutive sequence. So there is only one number. So for 3, again, I'll ask 3, do you have a 3? We do have a 3, and then 3 will call to 2, and then from 2, I'll go to 1, because I will keep decreasing my number, right? So here there are 3 calls. So there is if we assume that 3 is the highest number we have, so we have a sequence of length 3, which is a consecutive sequence. Similarly, for 2, we do the same thing, and then we'll get the answer 2. Okay, so here this way also we got the number 4, which is like the highest maximum length of the consecutive sequence. So this is how we can find this. But here are a few things that we should notice. The first thing is, we are calling 4 and then we have noted a result, but thing is the sequence for 4 would be 4, 3, 2, 1. This is how we are forming it. And now when we are checking with 3, are we not doing the same thing? So basically we are doing 3, 2, 1. And then when it comes to 2, 1, we are doing this 2, 1. So we are repeating these things that we have already done before. So how can we like avoid these particular repeated calculation values? Well, we could actually ask whenever, if suppose initially we wanted to find the sequence from 4, right? So I'll do one thing. What I'll do is, instead of immediately asking for, if I have the number 4 minus 1, I'll first check, do you have 4 plus 1 in the hash map? Why? Because look at this example. If I'm starting at 3 and I know for a fact that 4 also exists in this array, is there any point that I start from 3? No, because from 4 I'm already covering that consecutive sequence. There is no point in covering from 3 to 1 again, because I know if there is a number above 3, the sequence that is going to be is always going to be larger than the sequence that I'm going to get from 3 to 1, right? So there is no point in again making a duplicate calculation for that. Similarly, when I come to 2, I'll check, does my hash map has 2 plus 1 is equal to 3? Yes, it does. Doesn't that mean that I've already covered the sequence 3 to 1 somehow starting at a higher level? Yes. So I don't need to calculate again 2, 1. So I just need to make sure that I start off from a point where the consecutive number just above it. If I'm starting at 4, there is no such number as 5 in our hash map, because if there is 5 in the sequence, maybe at the end, what I'll do when I go to 5, I'll check, right? Does 5 plus 1 6 exists in my hash map? No, it doesn't. So that means I'm starting at 5 and then I'll go to 4 and then I'll go to 3. So if I'm already doing 5 4 3 2 1, is there any point of checking 4 3 2 1 length? No, because 5 4 3 2 1 is always going to give me the longest, which is what I need. So I don't need to make these redundant calculations from the lowest level. I hope you got my point here. All right, let's get to the coding part. We need a hash map, and initially we'll make sure that whatever the elements that we have, we'll put it in our hash map. Simply these, and then let's call it true. Now what are we going to do is, so again we are going to start the loop, and this time we wanted to find how far can we go down, right? If I'm starting at 4, right? If I'm starting at 4, I want to know how far can I go down by decreasing one number each time, so that how many times that I can go down is the maximum consecutive length that I can get, ending at 4, correct? Right. But if you remember, there's one condition that we need to check. If 5 exists, I should not make any calls from 4, because I will make sure that 4 3 2 1 sequence is already covered with 5 4 3 2 1 sequence, right? So the first thing that I'm going to do is, if whatever the number that is here at this plus 1, if this number that if this number is already in my hash map, then I don't need to do anything, right? I just need to continue, right? If that is not the case, let's maintain a count, right, which will be 1. So because no matter what happens, if a single number is there, that will be the longest consecutive sequence, which is why my count is 1. And now while let's put my current number, something like this, so that I can decrease my current number. While my current number minus 1, if this is in my hash map, if my current number minus 1, if this is in my hash map, what will I do? I'll increase my count, good, and then also decrease my current number. And then all I need to do is let us also maintain something called a maximum. So maximum will be math.maximum of my already existing maximum or the new count, right? And we'll return the maximum. Okay, there's one thing that we are not doing here. See, every time we need to make sure that we reset the count, right? Because every time we are starting at a new element and then we are trying to find from there on. So we have to make sure that after, before starting our count, we have to make sure that count is 1. Okay, let's see if this is working. Okay, looks like for the hash map, I directly put the index. What we need to do is we put the number instead, right? Because we wanted to put the number itself, not the index, because we need to know whether the number 104 or something like exists or not. Like expected, it's working fine. And let's see if it is working after submission. As you can see, the solution is working fine. And if you like the video, please give me a like and consider subscribing my channel if you wanted to receive updates every week regarding blind 75 questions, and stay consistent.